Hi gang, let's now add and subtract radicals, okay? So we'll work on the next problem here and I'll do some more examples. I'll do more examples than just this first one. So when you're adding or subtracting radicals, the first thing you want to do, step one, is actually to simplify the radical first, okay? So I'm going to go ahead and simplify these radicals first, and then I'm going to see if I can subtract them. Okay, so these are square roots, so I'm going to go ahead and look for the biggest perfect square. So the biggest perfect square in 24 is going to be 4. So I'm going to think of 24 as 4 times 6. Okay, now remember, for exponents you have to divide. So 3 is not evenly divisible by 2, so you have to take 1 off, right? Because if you take 1 off of 3, you get an exponent of 2, which is divisible by 2. All right, so I'm going to rewrite this as y squared times y. So you have to break everything into its perfect and non-perfect part. So let me just go ahead and simplify this first radical, and then I'll go to the next one. Now when I simplify it, because there's something outside already, I'm going to first write it on top. So the square root of 4 comes out as a 2. The 6 is left under. Y squared comes out as a y, right? Because 2 divided by 2 is 1, and this y stays under. So 2y is what came out. Whatever comes out gets multiplied by whatever's in front. So I'm going to do 2y times x. So I'll write this as 2xy. And inside I have a remainder of, not a remainder, what's left under the radicand, the non-perfect parts, are 6y. Okay, gang, that is the first part. All right, now let's do the same thing to the one in the back. Let my brain just write this a little bit more squished together. There we go. I like that better. Okay, now let's come over here. The biggest perfect square in 54 is what? Okay, so we're going to have 6 times 9. Okay, there's nothing we can do with the y. We're going to leave that under, and that x squared is already perfect because it's divisible by 2. Okay, so remember, this is square root, so for exponents you have to be divisible by 2. Okay, the 6 stays under, the 9 comes out as a 3. Again, I'm going to write it on top, and I'll first here. The 9 comes out as a 3 because the square root of 9 as a coefficient is 3. This stays under, and then 2, because it's an exponent, 2 divided by 2 is 1, so we have 1x. Now we're going to do this 3x, we're going to multiply it by the 8y in front. So 3 times 8 is 24, x, y, left with a 6y under. Now, just a tiny quick review here of when you can add or subtract. So it's the same idea as when you're just doing regular combining like terms. Like if I have 2x plus 3x, I know I can combine that to 5x. It's the same concept with radicals. If I have 2 radical x plus 3 radical x, it's going to equal to 5 radical x. So when we say a like term, it means that everything behind the leading coefficient has to be identical. So when we say that we have a like term, it means that everything behind the leading coefficient is identical. So they both have an x outside, they both have a y outside, and they both have a 6y under the radical. So these are like terms. So I can go ahead and do 2 minus 24, which is minus 22, of this type, which is x, y, square root 6y. Okay, gang, so that is the answer to the first one. Let's do another one, okay? So next one, now this again is a square root, so let's first break up the perfect and non-perfect parts under the radical. Okay, biggest perfect square in 8 is going to be 4. Biggest perfect square in d to the third is going to be d squared. Right, because 3 is not divisible by 2, so you have to pull 1 off to make it an even exponent. All right, let's just keep going with this. So the square root of 4 is 2. This 2 stays under. The square root of d squared is d, because you're going to do 2 divided by 2 is 1. This d stays under. And again, you multiply this out in front. So 6 times 2 is 12. You have a c squared and a d. Put it in alphabetical order. And then what's left under is a 2d. Okay, that's totally simplified. Let's take a look at the second part now. Now let's look for all the perfect squares in the second part. I'm just going to write that 9d outside. Okay, let's take a look. Nothing we can do with the 2. 2 is not, as a coefficient, is not a perfect square. That's c to the fourth. c to the fourth is already a perfect square. Okay, I didn't even really need to rewrite this because it's already broken down the way we need it. Okay, so let's go ahead and simplify. We're stuck with the 2 under. That's not a perfect square. Half of this, so 4 divided by 2 is 2, and this d is left under. All right, so we're going to pull this out in front. We multiply it out in front. We put it in alphabetical order. Okay, and that's what the back half simplifies to. All right, so now let's decide if these are like terms. Can we actually subtract these radicals? So again, how you check is everything behind the coefficient must be identical. To the absolute hair, everything must be identical. So 2c's out, 2c's out, 1d out, 1d out, 2d under, 2d under. Everything's identical, so I can actually do the subtraction. So it's 12 of this type minus 9 of this type will give me 3 of this type. Let me just make sure I got everybody. Yep, so that'll leave me with 3 of that type. All right, gang, that's the final answer on that one. Okay, let's do one more. This is now a fourth root. So when we look at the first one, there's nothing to simplify here. There's no perfect force under the radical. All right, but if we look over here, there's some stuff we can do, right? We can break down a few things here. I'll just work on simplifying this radical and then I'll pull everything down, okay? Okay, can't do anything with the 9. 9's a perfect square, not a perfect fourth. So that looks very appealing to us, right? We see the 9 under the radical, we want to go for it, but we can't, right? Because we're not doing square roots, we're doing fourth roots. Okay, now to be a fourth root for an exponent, you have to be divisible by 4. So we have a 5, so you have to pull 1 off to make it a 4. So C4C, C4C, same thing with the d to the 5th. D4D. So we're breaking it into the perfect and non-perfect parts. Okay, gang, so let's go ahead now and do the fourth root. So we're stuck with the 9 under. That's a square root, not a fourth root. C to the fourth, so 4 divided by 4 is 1. It comes out as C to the 1. This C is left under. D to the fourth, you do 4 divided by 4, comes out as D to the 1, or just D. And this d is left under. So this radical here is going to simplify to, right, and we bring this stuff that came out up in front. So C, D, fourth root, 9, C, D. All right, let me bring everything else down. There's my negative. Let me bring this guy down. 15, C, D, fourth root of 9CD. Okay. Okay, gang, now we're going to check if these are like terms, right? So we have to check everything behind the leading coefficient. Now, there's no leading coefficient here. So what do I assume it is if there's no number here? Good. We assume it's a 1. We assume it's a 1. The default is a 1 if nothing is there. All right, so let's check. We got a CD outside, CD outside. We got a 9 CD inside, 9 CD inside. They're both 4th root. Okay, so we look good. We can do the subtraction. So we're going to do 15 minus 1, which will be 14 of this type. Of this type. Okay, gang, I hope you found that fun. I think radicals are a lot of fun. I hope you enjoyed that, and I will catch you in another video. Bye-bye.